Welcome everybody to this backup recording of my presentation, Decarbonization Potential of Logistic 4.0 Technologies in Apple Supply Chains. I wrote this paper together with one of my students, Christina Papsch, and one of my supervisors, Fabian Behrendt, and I have the honor to present this paper today here to you. This is the agenda. I guess it's very similar to the other agendas you will be seeing today, so I won't go into the detail and just start with the presentation. As you all know, we have a climate crisis, and the climate crisis makes it necessary for us to decarbonize. So by reducing our CO2 emissions, we might manage to reach the political goals of a warming below 2 degrees Celsius, and this also makes the complete decarbonization of production and transportation inevitable. Looking at food supply chains, we can see that they are often very energy and transport intensive because the products have the attributes of seasonality, so they can just be produced at a certain time of the year, and most of the times they are also perishable, so we need cooling system or certain atmospheric control systems. The last thing I want to talk about is the Industry 4.0. Industry 4.0 or also the Logistics 4.0 are connected to connectivity, cloud computing, artificial intelligence, and many other modern technology. They promise us many improvements of our system, but those technologies are not only supposed to improve our processes, but also the ecological performance of supply chains. So I took this as a hypothesis that Logistics 4.0 will have a beneficial effect on the ecology or on the carbon emissions. So my first question I wanted to answer was, how can we quantify the carbon effect of those technologies? And the second research question, how big is the reduction potential of selected technologies in example supply chains? Coming to the next section of my presentation, the methods section. First, we needed to define a framework. What are Logistic 4.0 technologies? And as you can see here in this very simplified graph, it's not so much a binary answer, yes or no, if we have Logistics 4.0 technologies, but much more a gradual development from traditional logistics on the one side to a high level of Logistics 4.0 implementation. And I found this table fitting very well on this graph, or fitting together with this graph. And while we have the more traditional logistics technologies like the push principle or the decentralized vehicles, we will have more implementation of Logistics 4.0 on the right hand side. So there might be an open and flexible operations footprint. There might be a way to predict flows and streams. So we have a predictive inbound management. We have the possibility to implement autonomous vehicles, and so on and so on. The second step for our research was to calculate emissions of exemplary supply chains. I used the work of my student Christina Papsch for this because I could not do it on my own, and she did it very well. She did very well. So she looked into the literature and tried to calculate typical production for, on the one hand, typical emissions for a German supply chain, so a national sourced supply chain and a global sourced supply chain coming from New Zealand. There she looked at the production, the transportation, the storage, and the distribution in the end. and combining all together to the carbon footprint of the supply chains. So coming to the next step, step number 3 was to combine the Logistic 4.0 technologies on the one hand with the carbon footprint of the supply chain on the other hand. So the first question was, at which steps of the supply chain can we implement or deploy this specific technology? And if we can do this, how big is the reduction potential for each technology at each step? Here you can see the first slide with the results, or with a small excerpt of our results. We assessed on the one hand the deployability. So you can look at, for example, this column, and there we decided, okay, the technology, you can see it in this column, the complete global resource planning, at which steps can it be deployed? So everywhere we put a yes, there it can be deployed. It might be a little bit easier to understand when you look at the logistics routing, because obviously the routing and the real-time routing and connected navigation is only possible at those steps where we have transportation, where we actually have a routing processes. And after deciding if the technology can be deployed in those certain steps, we try to estimate the reduction potential. So, for example, the steps here with the logistics routing where we have a truck transport, the potential for CO2 reduction by optimized routing is rather low. It's estimated to be below 10%. So that's what we put there. It's a little bit higher for the ships routing because they are also very dependent on currents in the ocean and the strength of the wind and so on. So the routing and different routing, taking those currents and the winds into account, will have a bigger effect, or can have bigger effect than 10%. So we put medium here. And so like this, we did for all of the technologies, for all of the steps of the supply chains. So there were really many decisions we had to take, and many supporting data we had to look at to base our decisions on. Here you can see the first some more results, and it's more about an overview. So first, the question, how often can we use the certain technology in each supply chain? You can see in those lines here, again looking at the transport on the right side, the routing and the implementation of autonomous vehicles is of course only possible for the transportation steps, and those were 4 steps in the supply chain. So that's the 4, and the 6 is the rest, where it's not able to implement or deploy the technology. Those 4 steps here altogether sum up to 71% of the overseas supply chains emissions and 22% of the national supply chains emissions. So that's the amount we're talking about, which would be the maximum amount of reduction potential we can or could reach with this kind of technology. And of course, we will not reduce it completely. The reductions, we will reduce the emissions. We will not reduce the emissions completely by just implementing a new routing or a new type of vehicle steering. So those are the estimated reduction potentials. Here it's a little bit higher for the overseas supply chain and much lower for the German supply chain. Okay, so the first question we answered was, how often can we use the technology in the supply chain? Then, how much emissions are connected with those processes, and then in the end, how much can we actually reduce with our technology. So those are the overall results comparing the reduction potentials between the New Zealand supply chain and the German supply chain in blue, New Zealand, and green, Germany. You can see that overall for most of the logistics areas, so mostly the areas here on the right, inbound logistics, warehousing, intralogistics, and outbound logistics, the reductions we are seeing, or the reduction potential, is rather low, but it differs. So we have some areas, for example, the supply chain management, where we have much higher reduction potentials. But in general, we want to propose that those reductions are more of a side effect because of the low quantity. What we conclude from this is that just focusing on Logistics 4.0 technologies will not be enough to reach the political goals. We always need a combination with other technologies to reach those goals, because as you might recall, those goals are around 50% for 2030 and around 95% for 2050. So they are way out of reach with this kind of technologies. To sum up the presentation, this paper complements the qualitative assessment of Logistics 4.0 technologies by proposing a method to quantitatively assess the CO2 reduction potential of Logistics 4.0 technologies. We presented this method using some exemplary Apple supply chains. So we picked those because they are, on the one hand, a global supply chain, and on the other hand, a more national or regional supply chain. And yeah, we hope with this method to support planners and decision makers in supply chains to align their modernization process with the political climate goals, to decide, okay, if I want to implement this measure, will it be enough, or do I need additional measures to meet the actual goals set by either the politics or other stakeholders of the company. This is only the first step of our research, or my research. I want to focus on this kind of research in my dissertation project. So further research should include, or in my opinion, other Logistics 4.0 technologies, because as you might realize, the framework we used is not a complete framework. There are other technologies we did not look at yet, and there are other technologies which play an important role in Logistics 4.0 but are not assessed in this work. It also might be interesting to look at other supply chains. So looking at maybe Apple supply chains from different countries, or looking at other goods, transported goods, be it agricultural goods or consumer electronics, or even other goods. They all might have different CO2 reduction potentials, and I think our method will be, it's possible to apply our method also to this kind of supply chains. And in the end, as always, we need more data. So on the one hand, we need data from primary sources, as most of the sources we used were secondary sources about the real emissions or about the data on the supply chains. And on the other hand, we thought about not only taking into account primary sources, but also maybe generating more data by setting up simulations and then making our research more valid and based on more data. So thank you for this listening to this recording, and if you have any questions, I hope the internet connections is good enough to allow at least a live question and answer section. Thank you very much. And if you have any questions, we are very happy if you get in contact with us via email, or if you have any ideas or recommendations for us, please just send us an email and we will answer you back. Thank you.